Now, what can we do in order to obtain power amplification? It is very clear that the source of signal of interest, that cannot be the only source that is applied to the circuit, because then what you get out of the network will definitely be less than what you put in. Okay. So, there must also be an additional source of power. Okay. That is, you have some relevant input signal, let us say V1 or V in, and there must also be an additional source of power. So, somehow the power must be greater than the power that you put in from the relevant signal source. Okay. Now, this is quite common, at least even if you do not understand how things work, you know that an amplifier works with a battery or with some source of power. Okay. So, you have these public address systems in your classrooms and so on, they are plugged into the mains. I mean, that is so that they can draw some power from the mains. The actual signal is, let us say, coming from the microphone. So, the output power that goes into the loudspeaker is more than what comes in from the microphone. And how does it do that? It actually draws some power from the and converts it into additional power in the loudspeaker. Okay. What it means is the following. So, let me again take a 2-port network and let me assume that N is a linear 2-port network. Okay. Now, I said that I will have a source of signal and another additional source of power. So, to distinguish between the two easily, I will consider the signal source to be a sinusoid of some frequency and additional power source to be DC. Okay. Now, this is quite the common case, but it does not have to be. The additional source can also be a sinusoid, but the most simple form, the most commonly used form is where the additional source of power is DC. So, that is what I am going to consider. Okay. So, that is my input Vi is some peak value Vi hat cos omega t. Okay. So, by the way, this is not just a linear 2-port network, it is also passive. Okay. So, now the output is a sinusoid of the same frequency, because it is a linear network, and for simplicity I will assume that it is in the same phase. Okay. It does not matter if it is or if it is not. Okay. Now, again I have a single independent source in the circuit. Okay. So, this we know it cannot give you any power gain, but I am just going to go through it. And this current that is going into the load will be some IL hat cos omega t. Okay. We already know that defining the port variables like this V1 I1 and V2 I2 minus V2 I2, which is the output power is less than V1 I1. So, this circuit cannot give you any power gain at all. Okay. Now, what we can do is to add an additional source of power to this circuit somewhere. Okay. It can be anywhere, it does not matter, the same arguments will apply. But remember, this network is a linear passive 2-port network. Okay. Now, just for illustration's sake, let me assume that the additional source of power is something connected in series with the input source. So, this is the input signal source. Okay. And the additional source of power, let us say is another source that is connected in series. And let us say it has a value of V10. Okay. So, now we will have some VO and some load current, okay, and this will have a component due to Vi and also a component due to V10. Okay. All I am saying is that both of these sources will have some effect on the output voltage. Okay. So, that is a very general statement and very obvious. Okay. Now, the question is, if the power in the load due to the input source Vi, okay, because this is the signal source, this is the source that has useful information. Okay. So, as I said, I call this Vi hat cos omega t. So, the component due to Vi in the load, if it has more power than what is being fed from the left side, what is being delivered by the input source. Okay. And the answer, it turns out that it cannot, and the answer is very simple. Okay. Because this is a linear network, superposition applies. Okay. What does it mean? Let me copy this over. It means that the solution to this can be obtained by superposition. And what are the two conditions? Two conditions are, one in which only Vi is present and one in which only V10 is present. Okay. This is the load. Okay. So, the solution to this can be obtained as a superposition of this, where we have only Vi applied to the network, and this where we have only V10 applied to the network. Okay. This is because of linearity. Now, clearly the output voltage in this case, let us say VO1 and the load current IL1 are only due to the signal Vi, and the output voltage in this case, let us say VO2 and IL2 are only due to the DC source V10. Okay. So, if you compute the power that is contained only in the signal component, like I said, Vi is Vi hat cos omega t. Okay. Both IL1 and VO1 will be sinusoids, and their product is the power. Okay. In this case, we already know that minus V2 I2 is less than or equal to V1 I1. So, the output power due to the signal component is less than or equal to the input power due to the signal component. Okay. So, what it means is the following: if you have a linear network, even if you use an additional source of power, you cannot have an output power in the signal component that is more than the input power in the signal component. Okay. You will surely have an additional output power, because the voltage across this, for instance, if you consider this load as a resistor, the voltage across this will have components from the input source as well as the DC. Okay. So, there will be additional power in the load for sure, but that will not get translated to power in the signal component. Okay. Because by linearity, you can analyze the circuit with the signal and the DC separately. Okay, and we will assume that the signal is a sinusoid. So, the signal component of the power will only come from this one, and the DC component of the load power will only come from that one. Okay. So, even if you add an additional source, you are not going to get a higher output power at the signal component. You will surely get a higher power in the load, but that will not be at the signal component. Okay. Now, it is very obvious, and you can do the analysis yourself. This is not the only way to provide an additional DC source. Okay. You can provide it using a third port, but by linearity exactly the same thing will happen. You can always decompose the linear network into different circuits in which only one source is activated at a time. So, you can activate only the signal source at a time, you can activate only the DC source at a time, and from this you will conclude that the power in the output at the signal component will be no different from if you have only the signal input. Okay. So, the whole idea was, if you have only the signal input, the output power will be smaller than the input power. So, we thought we will add an additional source of power. Let us say we stick a battery somewhere, but that is not going to help if the circuit is linear, because once the circuit is linear, then whether you have two sources together or acting separately, the effect of each source will remain the same. That is what is meant by superposition. Okay. So, to conclude, passive devices mean P out less than or equal to P in. So, which means no power amplification if the signal source is the only power source. That is, if you have a box with an input and an output, and the input consists only of the signal source, the output power has got to be less than what is being delivered by the signal source. So, the next idea is an additional power source. Now, this you know by experience. You know that all your electronic gadgets work with a battery. Why is that? Because you need amplification and you need an extra source of power. Okay. So, that when you get a small signal, you can augment it with the power from the battery. Okay. So, that is the general idea, although you do not know exactly how it works yet. The idea behind this is, we can convert some power from this into the signal component. Okay. But this also does not work if you have a linear device, and of course, all devices are passive. Then the output power in the signal component is going to be less than the input power in the signal component. Okay. This is because with a linear network, okay, when you have two sources, that is the signal source and the additional power source, there is no effect on the output because of the signal source, just because you connected an additional power source. Okay. This is very easily seen when you decompose it into superposition with each source acting by itself. So, whether the additional source is there or not, the output because of the signal source will be exactly the same. Okay. This will be independent of the additional source. Okay. So, you cannot use a linear device for amplification. So, the very important conclusion is that we need nonlinear devices. Okay. Now, some of you may have already been exposed to the transistor or other amplifying devices, and you know that they are nonlinear. It's not arbitrary, it's in fact something that we need. If you have only linear devices, you could never get any power amplification. It's only with nonlinear devices that you need power amplification. Now, this also gives you a very good motivation for studying analysis methods of nonlinear circuits and understand them properly and so on. Okay. So, those things we will see in the following lessons. That gives you a motivation to study nonlinear devices and methods to analyze nonlinear circuits and so on, although they are more complicated than linear circuits. Okay. Because without nonlinear devices, we can't have any amplifiers, and without amplifiers, we can't have any of the wonders of the information age, because it's with amplifiers that you can build all the wonderful analog and digital circuitry that are all around us. Okay.